Hey everybody, it's Nate from Explorers.life, and I teach people how to build DIY campers. And in this video, I'm going to show you a complete start to finish video on how to install solar electrical system on a 1976 Airstream. Now this is a collaboration video with master woodworker Andy Rawls. Andy is a fellow YouTuber who makes some incredible pieces of furniture in the Texas Hill Country. He has been working on a frame-up restoration on his 1976 Argosy and reached out to me to help out with the electrical side of things. I was super excited to get the opportunity to help install the electrical system in a camper that is going to be out of this world beautiful by the time Andy is done with it. So special thanks to Andy for allowing me to help out on his project and for providing a great project for me to help teach even more people how to build DIY campers. Now this is a really long video, so I'm just going to jump right into the prerequisite information about this video that I think will help you if you're trying to mirror this system. Now if at any time you want to skip ahead, I provided some timestamps in the video description so that you can see what subjects we're going to cover, or you can just simply skip the intro if you wish. Now, first and foremost, Andy is a fellow YouTuber and has been documenting this renovation for the better part of a year at this point. He's also shooting a video over this very same electrical install at the same time as me. Now, his video is going to be from his perspective, and it's going to provide a different viewpoint on what I'll be showing you in this video, and I think it'll be highly beneficial for you to check out. Now, second, I have a blog post with a complete wiring diagram and parts list of everything we used to complete this project, all the way from the batteries in the inverter, all the way down to the lugs and the heat shrink. It's really a one-stop shop for this project. Also, if I feel like anything needs to be added or addressed that we didn't quite cover in this video, that blog post is where you can find that information. Remember, I can't edit the video after it's been uploaded, but I can edit the blog post to add more information or clarification as needed. Third, I will be making some references to other videos or blog posts throughout this video. A lot of these videos that I'll be referencing will be some kind of like basic skills that you'll need to complete this project if you're trying to mirror this system or just simply use this video as reference. Now, all of these links can be found in the video description. And lastly, before we get started, the sizing of this system was based off of a power audit that Andy performed earlier this year. The audit showed that he was going to be using about 300 amp hours per day on a heavy electrical usage day. Now this means that a 400 amp hour battery bank paired with 800 watts of solar was appropriate for his needs. And this system is also going to be capable to be charged with and operated by shore power as well as a generator if need be. Alternator charging will not be used in this particular system, but adding alternator charging to a system exactly like this would be fairly straightforward and play nicely with the components we've used. Now, enough wasting time. We've got a lot to cover, so grab a drink, sit back, let's get started. This is the enclosure that Andy has made to house all of his electrical components, and you can see that the 12-volt fuse block and the 120-volt breaker box have already been installed on the back wall with all of the branch circuits wired to it. The major components of this system will be 400 amp hours of Battle-Born lithium batteries, a Victron Lynx distributor, a Victron Smart Solar MPPT 15070 solar charge controller, a 3000 watt Victron Multiplus inverter charger, and a Victron BMB712 smart battery monitor. The next step was to play some electrical Tetris and find the best location for all of these individual components and to mount them on the wall of the enclosure. Now the Victron Multiplus inverter charger would end up right there. The Victron Smart Solar solar charge controller would mount right there, and after much indecision we decided to mount the Victron Lynx distributor right there. The batteries would eventually get mounted up on top of this shelf, which Andy left space for 2 more batteries for future expansion if needed. Next up was mounting the inverter. The Victron Multiplus comes with all of the screws and mounting plates and stuff necessary for mounting the inverter charger to the wall. So what we're doing right now is this is the backer plate that gets mounted onto the back of the inverter charger right there. And so Andy is just screwing that to the box that he's made, and we'll be able to hang the Multiplus onto that. This is essentially a French cleat system, so the backer plate mounts to the box, and then the inverter charger, there is a lip on the top back that mounts directly onto that flange, and the bottom is secured with 2 more big wood screws. After that, Andy used a cordless drill to mount the charge controller to the enclosure with 4 wood screws in the mounting holes that are on the flanges of the charge controller. Then he mounted the enclosure for the dual pole disconnect for the solar array next to the charge controller with some wood screws through the back of the enclosure box. The next thing was to mount the Victron Lynx distributor, but there are a few things we need to mount to the distributor before we actually mount the whole thing to the wall. We needed to mount the Blue Sea Master disconnect switch to the positive terminal on the Lynx distributor by means of using this piece of copper bar. Using a copper bar instead of wire and lugs reduces the number of connections that need to be made and therefore reduces points of failure and increases wiring efficiency. And then we needed to mount the shunt included with the Victron BMV712 battery monitor kit to the negative terminal of the Lynx distributor in pretty much the same fashion. A shunt is essentially the fuel gauge of your system. It will tell you how much power is leaving your batteries or how much power is being pushed back into your batteries. Now, although not necessarily a required component, not installing a shunt would be like driving a car without a fuel gauge or a speedometer. To finish up mounting the main components, Andy mounted the Lynx distributor in place on the wall using 4 wood screws. Now, the next step was to make the wires that would run from battery to battery. The user manual for the Victron MultiPlus 3000 calls for 4-aught wire to be used to supply power from the battery bank to the inverter charger. So we're going to use that 4-aught wire not only for those wires that are going directly to the inverter charger, but also for all the wires going all the way back to the battery bank, as well as the wires that connect the batteries together. Now, making these wires consists of cutting the wires to length with some 16-inch cable cutters, stripping the ends off with a cable knife, and crimping the lugs onto the wires with a huge wire crimper. Next, we use a heat gun to shrink some pieces of 3/4 inch heat shrink onto the cable. Once those wires were made, it was time to start fitting them onto the batteries to wire the battery bank together. So this is where the batteries are going to stay, and so the batteries are best going to be in this configuration for these. These are wired in parallel, which means negative to negative to negative to negative to the Lynx distributor, positive to positive to positive to positive to the distributor. I'm going to just wire this up just off camera, and then I'm going to circle back around and we'll kind of show you how it's wired, because since those two are reversed, like they're just turned around backwards, it's going to kind of be a little confusing to just try to explain it, so I'm going to get started on that. Lining all of these batteries up side by side would have been the best option, but they didn't quite fit on the platform like that. So if you're trying to mirror this build, consider making the area that you store your batteries able to fit the batteries in a side-by-side manner. Okay, so we have all of these wires loosely fitted right now, so they're just barely on there. We are trying to get these so that they actually fit. Now that we know that they fit, we are going to actually permanently connect them. And so we're going to take all of these lugs and we're going to sand off the backs of them just a little bit so we make sure that there's no burrs and that these fit totally flush with the battery terminals. And we're also going to rub them with some rubbing alcohol, and that's going to get rid of any of the grease from our hands or anything like that that's going to be on the backs of these lugs and make a really solid electrical connection. So earlier on in the video I showed, we made like 3 of each of these, and since we had to position these batteries like this, that was a little bit of foresight, that's the wrong word, a little bit of just poor planning on my part. We had to make longer ones for this one and for this one here. So that was just something that I kind of made an error on earlier, but it's not that big a deal. One other thing, because I know I'm going to get a question about it, is the length of this particular wire. So this wire and this wire are effectively the same position in the battery bank. And these technically should be the same length, if we're doing this textbook, which we're trying to do as close to as possible. But this wire is going to be longer than this wire by about, 8 to 10 inches. And it's okay. We're okay with that. Like if you were setting this up in like a lab type scenario and you're doing like testing and stuff like that, it probably makes a little bit of a difference. But real world, it may not make that big of a difference. So that's what we're going to do for this decision we made. And so I'm going to get all this stuff wired together. We're going to get the battery bank wired to the Lynx distributor, and then we get to finally move on to the rest of the components. So a quick little getting up to speed. So we've got everything mounted. I think we showed that already, but Andy just mounted up the A&L fuse and fuse holder right there. And that's going to be the main fuse for the system. That is a big beefy Blue Sea fuse and fuse holder. Particular fuse holder is rated up to something crazy like 750 amps. And this fuse is a 400 amp fuse as spec'd by Victron for the inverter charger. And we can't focus on that. So we just, Andy just used a hole saw to cut a hole there because this is going to go back to our chassis ground in the back that we're going to crimp on in just a second, as well as be able to feed power from the Lynx distributor over to this positive and negative on the distribution for the fuse block. And that's what that hole's going to be. And we got a few more holes to drill, and so we're going to get to that. This wire is the chassis ground wire that attaches to the frame of the Airstream. Andy cut out a tiny section of the wall paneling and attached a wire lug with a bolt to the metal frame of the Airstream, where we then crimped on a 4-aught wire to attach to the negative terminal of the Lynx distributor on the load side of the shunt, right here. Okay, let's talk about what we've got going on here. So battery bank is fully wired up. We've got battery 1, battery 2, battery 3, and battery 4. So we've got negative to negative, to negative to negative, positive to positive, to positive to positive. And we are going to attach this wire, this red wire here, to battery number 1 positive. And we're going to attach black wire, focus, to battery number 4 negative right over there. And I think I talked about this earlier, but it needs to, on a battery bank, the positive and the negative, they need to exit the battery bank on opposite ends of the battery bank. So positive from battery 1, negative from battery 4 to the distributor. So those are going to go to the bottom of the fuse right there. And then the negative that we're talking about is going to the bottom of the shunt right there. And we are connecting them in this order, the battery bank together and then the distributor together, because we want to connect the distributor to the battery bank, because right here this shunt and that connection right there, that's only about probably 1.5 inches away from each other. And so if we accidentally touched those two whenever they were already connected to the battery bank, that's going to be a bunch of fireworks that we do not want. So I see we're missing a bolt right there, so I'm going to add that bolt, and then we get to connect the battery bank to this, and we have power. Now, backing up just a little bit, you'll notice that the main fuse is already in place. I failed to show that getting mounted on video, but that is a Blue Sea A&L fuse holder capable of handling amperages up to 750 amps. And installed on that fuse holder is a 400 amp Blue Sea A&L fuse. That will be the fuse that will protect the wire going from the battery bank to the Lynx distributor. So that fuse is actually best placed as close to the battery bank as possible. But being short 2 battery lugs on site and on a time crunch meant that we needed to place it where I just showed. And this is fine though. ABYC says that as long as the wire from the battery bank to the Lynx distributor is 72 inches or less, the fuse can be installed at any point on that wire. That run is only about 24 inches or so, so although not perfectly ideal, it's still acceptable and code compliant. Now, if you're trying to copy this install, placing the fuse as close to the battery as possible is still the best option. Okay, so now that the battery bank has been wired in over here, the next thing that we're going to do is we're going to start on the components. So we have power to the Lynx distributor, which is right there, and we're going to start wiring up the multi-plus inverter charger as well as the charge controller. So it's just a matter of making more wiring connections, and we are going to get started on that right now. Now that the power is ready to be supplied to the Victron Lynx distributor at the turn of a switch, we can now start wiring the main components of the Lynx distributor. And to get that started, we needed to make another half dozen or so wires. 4/0 for the inverter charger, 2 gauge for the charge controller, and 6 gauge for the 12-volt fuse block. All of the wires that attach to the Lynx distributor have 5/16 inch wire lugs, and the wires that attach to the inverter charger have 5/16 inch lugs as well, and the wires that attach to the charge controller and to the 12-volt fuse blocks have ferrules. So just got finished cutting up all these wires and putting ends on them. Some of them have ring lugs on the ends of them, some of them have ferrules on the ends of them, but ultimately they will all go to these various parts over here. We'll kind of talk through that once we hook all that stuff up, which is going to be next. We chose to do all of the negative and equipment ground wires and then wire in the positive wires. Now here's a rundown of where all the individual wires will be connected to the various components in this system. So we've got our Lynx distributor here. So we got positive, negative. We talked about this earlier. So these match up. So we've got positive, this is going to be a fuse here, positive wire is going to attach here, and the negative wire is going to attach here. So the positive and negative here is going to go to the 12-volt fuse block. Positive and negative here is going to go to the MPPT charge controller. Positive and negative here is going to go to the Victron Multi-Plus inverter charger. And then this one is not going to be used, but this one is commonly used for like alternator charging. So if you're going to run it to an isolator or like the Victron Orion DC to DC charger. This stud right here in the middle is going to be the equipment grounds for the inverter charger as well as the MPPT. So 4/0 to the inverter charger, and then 2 gauge to the MPPT. So we are going to wire. So scrolling around here to the other side, this is the inside of the inverter charger. We already took the cover off, it's just a matter of unscrewing 4 screws. And we're going to be connecting the positive wire from the Lynx distributor to one of these terminals, the negative wire from the Lynx distributor to one of these terminals, and over here at the MPPT, we're going to do battery positive and battery negative. So the equipment grounds I was talking about, those get connected right back here. So we're going to connect that one to that one. It's kind of out of focus. And then there's another one. We're going to turn the camera sideways because it's way on the bottom. And this is the equipment ground underneath here. I had to bring a light under, it's kind of dark. And so that's going to be connecting to that center stud on the Lynx distributor, as well as the equipment ground on the MPPT charge controller. Now, it doesn't particularly matter what order the components get wired to the Lynx distributor, but since all the negative wire terminals inside of the Lynx distributor are behind the positive wire terminals, it's best to do the negatives first, just so that they can be accessed easily. Okay, so we took the bolts off, and when you're doing this, the fuse is going first. So we've got a 100 amp fuse for the 12-volt distribution panel. And then the next one over is the MPPT charge controller, which is going to get a 150 amp fuse. And this comes pre-installed on there. Just slip that off like that. And then we're going to put that on there. And then we'll put that back. You just don't want this between your fuse and the bus bar, as it'll create some resistance. 400 amp mega fuse for the inverter charger. And that's it. Now all the wire lugs to all the individual components go on top of here. Bolts, washers, lock washers, they go back on there. And that will be it for this side of things. Also, good to note that your switch is off, so we don't have power coming to this bus bar, because you're working in close proximity with positive and negative at this point. So we don't have power here. and so this is not really a safety hazard. Installing the fuses and positive wires is just a matter of positioning the fuse, the positive wire lugs, washers, lock washers, and nuts back on their respective place on the Lynx distributor. Okay, so the Lynx distributor is all finished, I think, for now. We got these fuses, they're in here in place. Washers, lock washers are all in here, good to go. So the orientation goes fuse, then washer, lock washer, then nut on the top. Then on the bottom it goes fuse, wire lug, washer, lock washer, nut. And just be sure to tighten these down to the specs recommended in the Lynx distributor manual, and it'll be good to go. So now we're going to move on to all of the wiring over there for the charge controller and the inverter charger. Actually, we forgot to put these back. Like you remembered. Yeah. I forgot to put these back on there. So this is just what separates the positive and the negative bus bars, wires or whatever. Anyway, I'm gonna pop these back on. I think I can get them on without taking the wires off, but we're about to see.
Cross your fingers.
Yeah, those just pop back into place, so we're able to do that, thank goodness. Yeah. Okay, so we just finished up all of the DC wiring that's not the solar panels. So I'm gonna give a quick rundown of how all that is wired. Okay, so we're going left to right on here. So, and you know, this is just in this particular build. Positioning on this bus bar doesn't particularly matter if you want to have your inverter charger over here, your charge controller over here or over here, totally fine, doesn't matter. Okay, so in this one, we've got a 100 amp fuse protecting the positive wire. That is the positive 6 gauge wire going to the DC fuse block. Right down there, red wire coming into that thing. And if you need more info on how to wire up all of this, I have a full detailed tutorial on that, which I'll link to top right corner. And the negative wire on that is behind here, and that goes to this terminal over here. Okay, that completes the 12 volt branch circuits on the Lynx distributor. Next one up is the charge controller. So we've got a 150 amp mega fuse protecting the 2 gauge wire that is going down and around over to the charge controller over there, going to the battery positive. And return loop is battery negative, coming down and around, and back up to the negative bus bar in the back here. Skipping this for now. So here is the 400 amp fuse that is protecting the 4-aught wire that is going down into the positive terminal on the Multiplus 3000, and that is coming back. Return loop, 4-aught wire, 4-aught black, and that's going back into the negative side of the Lynx distributor down here. This one is the equipment ground, and the equipment ground goes down and it connects bolt back there, and then that connects also to the MPPT. So that equipment ground, let's explain what that is right now. So that equipment ground is a safety feature. And so effectively, if a catastrophic failure happens inside the MPPT, or more specifically the inverter charger, and let's say the positive wire comes in contact with the outside casing of the inverter charger, like if something melted inside, like I said, catastrophic meltdown, failure type of situation, the case would then transfer that power back to the Lynx distributor, and power would be allowed to flow through that circuit and would allow that fuse to blow. So if during the catastrophic failure the fuse didn't blow and the positive wire touched the case of the inverter charger, that would allow power to flow, which would then trip that breaker. Same thing on the Multiplus. Now, why do we use such a big wire for the equipment ground? It's a pretty common question I get, And ultimately that's an ABYC requirement, which is the American Boat and Yacht Council. And it says that the equipment ground can be no smaller than one size smaller than the current carrying conductors that are supplying power to the inverter. So we use 4-aught wire for the inverter charger, which is recommended by Victron. And so the smallest we could use is 3-aught. Now, it doesn't really make sense to buy just a few feet of 3-aught. It's not very cost effective, and there's no reason to not use 4-aught. So it's just easier, less expensive to just use the spare piece of 4-aught that we had. So that's kind of the rundown on the equipment ground. So now everything is connected on the battery DC side of the system. So the next thing we're going to do is we're going to crawl up on the roof and we're going to start wiring up our 800 watts of solar. We're going to head back to the diagram for the sake of clarification on this. These are the panels on the driver's side, and these are the panels on the passenger side. All of these panels will be wired in series, which means that positive and negative wires of neighboring panels will be connected together, and the positive and negative wires on the ends of the series string will be wired back to the MC4 combiner right near the roof entry gland. The same thing will happen on the other series string on the opposite side of the camper. And this configuration is a series parallel configuration known as 4S2P, which means 4 panels in series with the 2 series strings in parallel. The array is wired like this to stay under the maximum input voltage of the charge controller while still delivering enough voltage to the charge controller so that the MPPT charge controller has plenty of voltage to function at its peak performance. Okay, so we are up on the roof now, kind of get the lay of the land.
Yes, sir.
Here. So here's the front of the camper up here. We've got 2, 4, 6, oh that sun's bright, 8 panels back here. These are new power 100 watt panels, each of them. And so the way we're going to be wiring these is we are going to wire these in series parallel. On the driver's side, those 4 panels are going to be in series. Passenger side, those 4 panels are going to be in series. And then those 2 series strings are going to be wired in parallel. So these panels up here, this one and this one, that's bright, sorry about that. Those 2 can reach each other, those wires. The wires from this panel to this panel can't quite reach, so I need to make an extension cable. It's going to be about 1 foot long to make this panel and this panel reach, and that's not a big deal. That's pretty common to do. It's going to have a male MC4 connector on one end and a female MC4 connector on the other end. And I'm going to make them pretty quick on this particular video, but I've got a full tutorial on that I can link up there somewhere, that if you need to learn how MC4 connectors are made, that's where to find out that information. So I am going to get started with that. Now, when working on solar panels, it's very important to not be a dummy like myself and work on panels that are exposed to the sun. So when the sun is hitting the panels, there is electricity present on the wires. So when working on the solar array, you really should cover up the panels with the cardboard from the boxes that came with the solar panels so that they won't produce electricity. Now, the solar array wiring process involved basically just a lot of climbing up and down the ladder and going from panel to panel, making the MC4 connections as previously mentioned. Now, as I was wiring these together, Andy got started fastening down the solar panels to the L-track that he had already installed, and he showed in his last video that I'll link to in the description. So here's a breakdown of the solar panel array wiring from the panels all the way back to the roof entry gland. Okay, so we just got all of the solar panels wired up and secured down. So we've got array number 1 on one side, array number 2 on the other side, positive to negative all the way down to the end, and then that's coming all the way back here. Same thing on the other side. These 2 series strings are wired exactly the same. And it probably make the most sense if you actually check out the wiring diagram for this, which is in the blog post for this video, if you're confused about how this particular process works. So I'm going to show you how all of this stuff gets combined. And so we've got the roof entry gland is right there, so that's going down to the solar charge controller. And then we've got MC4 connectors here and here, and we've got splitters here and here. I guess I guess those are actually combiners, so there and there. And then we've got positive and negative coming from array number 1, positive and negative coming from array number 2. I already checked the voltage on these with a multimeter, and this one was like at 70 volts, and this one was like at 75 volts, which is what we would expect to see from the way these panels are wired. So now it's just going to be a matter of connecting all this together. There's only one way that can go at this point. So that goes on there, that goes on there, and then negatives, positives go like that. So I'm gonna get these clipped together, and then we'll show a quick view of what it looks like after it's all wired. Wiring an MC4 combiner to MC4 connectors is pretty straightforward, and I have a tutorial that I can link to in the video description for that process. Now this array does not need MC4 fuses in this location because the short circuit currents from all sources do not exceed the ampacity of the conductors for the PV module from NEC 690. Okay, and that is how that connects right there. So positives are heading down towards the charge controller there, negatives on that side. The entry gland is not secured down yet. Andy is going to do that later because we got some more stuff to do up here that's not really solar related. But he's going to use just VHB tape to tape that entry gland down to the roof, and then Sikaflex sealant over the top, or Dicor, or whatever it's called, over the top of that to make sure it stays down nice and tight. Now the next step was to head inside and wire the solar array to the charge controller. Now before we did this though, we disconnected the MC4 connectors at the MC4 combiner up on the roof so that there was no electricity actually flowing down into the camper. So with those panels wired in series like they were, working with exposed copper wire would have delivered about 80 volts worth of shock if we would have touched the bare wires, which would have been less than pleasant. If you had the panels covered up like I recommended earlier, that would also be sufficient, but being double safe would also mean disconnecting the MC4 connectors at the MC4 combiner in addition to covering up the panels with the cardboard. Figure it out, I hope. But anyway, power from solar is going to come into this box. It's going to go positive and negative. It doesn't particularly matter which one's which. And then positive, negative on the respective sides down here. And then that's going to go to the charge controller. All this stuff is 10 gauge wire all the way from the panels over to the MPPT. So we're going to get started on that, and then we will have solar power to the charge controller. Okay, so we got this all wired up. So these two wires, that's really dark. Okay, so we got this all wired up. These two wires, these little guys down here, these two are the ones that are coming in from solar. And then these two are the same ones. They just come up through this gland here, and they come into this, this disconnect here. Now this is technically a breaker, but it's being used as a disconnect. The way that this particular array is wired, we don't need any kind of fuses or overcurrent protection. So this is a 40 amp DC rated breaker, and that is what we're using here. It is dual pole, so it's negative on this side, negative on this side, positive on this side, positive on this side. And the reason we do this is because it's a NEC requirement. So that's why we do that. And then from the out, it's coming out and going into the PV positive and minus at the bottom of the charge controller. So now that we have that all up and running, we have power to that. The switch is still off. We don't really want to turn that on until we get the battery switch turned on. Although it won't hurt anything with the Victron equipment, the charge controller will just cycle on and off and on and off and on and off indefinitely until it senses a battery voltage, which we just don't want that. It's not going to hurt anything, but we don't want that. So the next step is going to be connecting shore power. Then after that, we are going to connect the inverter charger to the AC breaker box. And then after that, we are going to attach the various sensors and like voltage temperature sensor and the sensor that powers the BMV and little bitty stuff like that. And so that's kind of the next steps from here. So these are the three wires that are coming in from shore power. We got positive, neutral, and ground, and they are going to go into AC1, which is these three terminals here on the left side, right here. We've got line is on the left, neutral, and then ground. line is black, neutral is white, and ground is green. So we are going to connect these up. Already got them stripped off. I'm going to put some ferrules on them. I'm going to put in tutorials on how to cut, strip, and apply ferrules in a different video. So if you need tutorials on that, link top right corner. 2 minutes later. Okay, so we got this all connected, line, neutral, and ground, black, white, and green into there. And the next thing we're going to connect is we're going to connect our 6-3 wire into these 3 on AC out 1. Same thing, black for line, white for neutral, green for ground. Okay, so the next thing that we have to do is going to be attaching the inverter charger to the AC breaker box. And we're going to use 6-3 wire on that, and a common question I get is, why are you using 6-3 wire? We've got 10-3 wire coming in from shore power and 6-3 going out. And let me explain that real quick. So the reason we were going to do that is we have 30 amp shore power coming in on the 10-3 from shore, and the Victron Multiplus has what's called PowerAssist. And what that means is that it will take power from shore, and then it will add power from the batteries if needed. So for example, if we have 30 amps from shore power coming in, and Andy needs to run his air conditioner and his coffee maker and his space heater all at the same time, then it will take that 30 amps from shore power and it will add up to 3,000 watts of power from the inverter from the batteries to shore power. So you've got, quite a bit of power available, which that would be 30 amps from shore and 3,000 divided by 120, something like 25-ish. And so basically you'd have 55 amps available. Now we're going to cap that off at 50 amps with a breaker on the main breaker in the AC distribution panel, but that's why we have to use such a big wire to do that, and that's really just to let the Multiplus do its thing and use that particular function of the device. Now, getting the 6-3 wires to fit into the Victron Multiplus is honestly a pain in the ass. The wire gland directly below the AC output is too small to fit without removing the little rubber grommet that's inside of the wire gland, and it definitely won't fit with the outer insulation of the 6-3 wire attached. Now, the most correct way to do this would be to punch a hole with a metal punch and install a larger gland, but I'm going to guess that 99% of us DIYers are not going to do that though. So removing the interior rubber grommet and having the interior insulated wires exposed without the outer sheath is the best we can do without fairly extensive case modification, but I digress. Putting ferrules on the ends of this stranded wire and using a set of these needle nose pliers is key in getting these big wires to fit. Okay, so that is connected there, positive, neutral, and ground to the inverter charger. Now we're going to move over that way, and we're going to connect up the 50 amp main breaker into the break box, so we have some power over there. Now, I initially crimped some ferrules onto the ends of these wires, but then I found out that the wire and the ferrule wouldn't fit into the neutral and ground bus bar. So I just simply chopped off the ferrule and went with just the bare wire, which is totally fine. Just make sure to get every single strand of copper underneath the screw. Now here's a bit of behind the scenes commentary about how we temporarily hooked up the little outlet on the back of the breaker box so that we could turn on and test the system. Okay, cool. So now we have power to this outlet, so we can use this outlet to test the system, charge up whatever we wanted to, that kind of stuff. So this is good enough for now. I have a tutorial on doing this whole thing that's more in-depth. Link in description. I think I'm running out of top right corner links, so you check that out there. So we've got our 120 volt AC plugged into the AC distribution or the AC breaker box, and we have that little outlet on the back of the breaker box wired up so we can actually test some stuff. But now it's time to actually go through and check things out. So we checked for a few little checks before we actually turned everything on, and we already did these off camera, but I am going to talk about how we did it. I have some pretty.
The light's pretty bad there.
Pretty harsh lighting here. But things I was really wanting to check was the voltage between this and this. And that was 13.6 or something like that, and the polarity was correct, so that was good to go. So that means this is pretty much safe to turn on. We went through and we systematically traced all of these wires back to where they were going to go to their individual components. We did that. This portion of it is just so important to be really methodical. I personally like to touch every wire, be positive to positive, negative to negative, so on and so forth, to make sure everything is totally correct on that front. And that was pretty much it. We tested voltage here and here, and we got, it was like 72 volts or something along those lines. So that's what we did kind of off camera. I just want to talk through that. And now we're going to actually power it up, and we'll let Andy do the honors on this.
Yes. All right. 2 days of work. There we go.
So we turned it on. We see some lights down in the DC fuse block. Those lights are just telling us that there's a fuse blown, which there's no fuses in that. That's way down there, and so that's a non-issue. So we have power. We saw no sparks. We saw nothing like that. So let's go ahead and turn the inverter on.
I flipped this up, right?
I believe so. That plate is off to your left.
Oh, yeah. Yep, that's right.
Yeah, so up is on.
On, yeah.
And so we've got a little green light that tells us we're good to go there. No weird sounds. We can kind of hear it, but it sounds like a computer fan, basically.
It's a lot quieter than I thought it would be.
Yeah. Okay, so now we have power being delivered ideally to the AC breaker box. So Andy, you can go ahead.
The fan should work now. All right.
So we have a fan over here. I'll go ahead and turn that on to 1.
Let's see. So we're gonna click these on right here, right?
Yep. Turn the 50 amp main.
50 amp, and then the other one. And we got power.
Okay, can you hear it?
Knocked it out of the park, man.
So we have power here. So the next thing that we're going to do is we have a few sensors and stuff to wire in. So we're going to install the Victron VE bus smart dongle to the Multiplus, and then we are going to, and that'll let us be able to see our power coming into and out of this, and then we are going to be able to check on the app to find out about solar charging. We haven't turned the solar charging on because we want to see on the app what that looks like whenever we actually turn that on. So we're going to do some sensors and some apps, and all that is coming right up.
Cool.
Now I assure you I was more excited than I sounded in the video, but it's always just a little nerve-wracking to go ahead and turn that switch for the first time. But tracing all of the wires and making 110% sure that they are all going into their proper spots in the components should greatly reduce the risk of wiring something incorrectly. Now the next step is to connect some sensor wires. So the next thing that we're going to install is going to be a few of the communications cables. So this is the VE bus smart dongle, and this is going to allow us to connect via Bluetooth to the Victron inverter charger, and this is how it gets power. So positive, negative. We got B plus, B minus, that's battery positive, battery negative. And this is just going to go onto a positive and minus into the Lynx distributor. Just nice and simple. This one is going to go, this positive is going to fit onto another positive terminal. Inside the, this is actually going to sit on the, inside the Lynx distributor, and that way this supplies power to the BMV712 battery monitor shunt. This Ethernet cable just goes into the backside of the VE bus smart dongle on one end and into the inverter charger on the other end. So we're going to wire this stuff up. All this stuff is pretty simple, positive to positive, negative to negative, and this to the appropriate spots. Circle back around after it's connected to see where everything goes. So let's talk about the exterior shore power connection. Andy has a bit more work to do on the bumper area of the camper, where he's going to mount the 30 amp exterior shore power inlet. but we wanted to temporarily wire this in for the sake of this video and for the sake of being able to make sure that the shore power connection actually works properly while I was still there. Okay, so we got everything hooked up inside. We kind of messed around with the app for a little bit. Talked about the solar panels, you know, only producing 30 watts. That's fine because we're completely in the shade. There's a huge oak tree.
Big old oak tree, yep.
Huge oak tree like right over us. So ultimately, solar panels only work when they're in the sun. We are pretty much totally shaded in, and we'll be able to check tomorrow morning. But 30 watts seems reasonable for that. But what we're going to do now, so Andy has more work to do on this particular part. But for the sake of the video, we're going to hook up. We're just basically going to mock up the shore power connection here, and that's going to look like that. And all that is a matter of connecting white cable here, black cable here, green cable here, and that is, we zooming in? I don't know, I can't tell. Here. Those three connections right there. Hey, there we go, there's some light. Those three connections right there, black, white, and green, from the shore power that we've got connected into the multi-plus inside. And then we're just going to plug that into a 30 amp to 15 amp converter, and we're going to plug that in just to make sure that shore power is like operating as it should. And that will be pretty much all of the tutorial for the most part. We changed some of the settings inside of the MPPT and the BMV712. That stuff is straight from the Battleborn website, so we're not going to necessarily put that into the video, and that stuff's pretty dry, and I don't want to just recite numbers to you guys. So I'll put links to that in the description as well as the pinned comment below. And if any of this at any time doesn't make any sense or you need clarification, please ask in the comments. I try to respond to each and every comment to try to clear all this stuff up. And even if I don't have a video or a blog post on it yet, I will put it in a queue to make a blog post or a video for it, or point you in the direction that you can investigate and find out this stuff on your own. So that being said, we're going to do this. That's going to wrap that up, and then we're going to do some like cable management, and then we'll do a full system walkthrough, start to finish. It's going to be a little repetitive if you're still watching the full entire video, but hopefully it'll tie everything together in a more start to finish manner of how power flows through the system. Let's get started. Now this is a typical 30 amp RV shore power connection with a hot, a neutral, and a ground, black, white, and green respectively. Now if you find yourself at a place that does not have 30 amp shore power, say at a friend's house who's letting you use an outlet in the garage for shore power, you can get a simple 30 amp to 15 amp shore power converter that just plugs onto the end of the 30 amp shore power cord. These only run about $10 and is a very good thing to have on hand anyway. Now this would also be a good place to have a surge protector and circuit analyzer on the end of this 30 amp cord that you would plug into the 30 amp shore power pedestal at a campground. Okay, so we've got 30 amp shore power connected in here, but actually it's 15 amp shore power because we have it connected to a just a little adapter that goes into the wall in there. Connected up to the app, we've turned it on. And I've also changed the AC input 1 current limit into 10 amps so we don't trip the breaker that's in there. And that's all found inside of the VE Bus Smart dongle. So we can see that we're bringing 1,097 watts into the batteries at this point. And so we're charging, and we'll set the parameters according to... And so that's good to go. All the parameters for the charging were already on the inverter. It was pre-programmed by Battleborn Batteries because Battleborn Batteries is a distributor of Victron products. So if you buy through them, they can pre-program this stuff for you. I think they do it automatically, but it doesn't hurt to always put it in the purchase notes or whatever. But we can see all that information here. We could even hop over to the Smart BMV here and check out what that says. And it's saying that we're charging at 67 amps of 12 volt DC current. So everything looks like it is working perfectly, which is pretty exciting. So we've got everything totally wired up. This is day 3. We finished everything yesterday. and today was all about testing and shooting a little bit of video trying to explain how the system actually works. And a little bit of this will be repetitive, but hopefully it'll tie everything together. So the next thing I'm going to talk about is going to be how the system will provide power to 120 volt outlets. So when we need to have 120 volt power at the outlets around the camper or even run the air conditioner, and we're doing that only off of battery power, not on shore power, here's how the flow of power works. We have our four 12 volt 100 amp hour battle-born lithium batteries, and they are wired in parallel, which means positive to positive all the way around and negative to negative all the way around. And the positive and negative wires exiting the battery bank here and here are exiting on opposite ends of the battery bank. So battery 1, 2, 3, and 4. So once the power leaves the battery bank, it is going to the Lynx distributor through the fuse there, that is the main fuse of the system, and through the shunt that is right there. The only thing that is on the battery side of the shunt is the batteries, and all loads are on the opposite end of the shunt. Power flows through the positive and negative bus bars inside of the Lynx distributor and goes through this 400 amp mega fuse. Now the positive and negative wires exit the Lynx distributor through those two wires there, and they connect into the Victron Multiplus 3 kVA here and here. That supplies 12 volt DC power to the Multiplus. Then the Multiplus converts that 12 volt the 12 volt DC power to 120 volt AC power and sends it out of this black wire. Well, it's the green, white, and black wire that goes there. And that circles around and just loops behind that breaker box. And it goes into this breaker box down here. Power comes into this 50 amp main breaker, and it energizes the bus bar in the back of this distribution panel, and it sends out power through these branch circuits. 1, 2, 3, 4. 1, 2, 3, and 4. And then from there, all of these are wired into each of the individual branch circuits in the system, and that powers all of the outlets as well as the air conditioner and items like that. Now, if we're connected to shore power, this white cable right down here is connected to the shore power inlet on the back of the camper, and that flows into the inverter charger, and that flows into the charger, and then it will flow back out of that same wire we just talked about, that black one that goes to the 50 amp main breaker over there. And this is flowing in at 30 amps and can flow out at up to 55 amps due to the Victron PowerAssist function of this inverter charger. Power will flow directly through without being inverted because we're going from 120 volt AC power to 120 volt AC power, so no conversions are necessary. And whatever power is not being used by through the outlets or the air conditioner or anything like that, the inverter charger is going to use the charger function and is going to send power back out through these two wires in reverse through the Lynx distributor, back through these wires, all the way back up to the battery bank to charge the battery bank. Power can flow in either direction or kind of both at the same time. That may be a little bit of a confusing way to say that, but ultimately wires are bi-directional. So now that we know how the system provides power to the 120 volt outlets, let's talk about how the system provides power to the 12 volt devices such as like lights, fans, 12 volt refrigerator, which I think he's using, and that kind of stuff. So to power the 12 volt devices in the system, we have the same thing that we just talked about. 4 12 volt 100 amp hour battle-born lithium batteries wired in parallel, 1, 2, 3, 4, with the positive and negative exiting out of opposite ends of the battery bank. Positive and negative wires going over here through the 400 amp main fuse, through the master disconnect switch, negative wires coming through the shunt, and through the positive and negative bus bars inside of the Lynx distributor. This is where the DC, this is the circuit that will go out to the DC fuse block. So we've got positive and negative wires, got a 100 amp mega fuse right there, and that is coming over into positive and negative side of the DC fuse block. Now we have spaces for, I think it's 12 different circuits right here. Those are not all wired up yet. Andy's still working on those, but ultimately we have power to this and wiring everything up downstream of this 12 volt fuse block is kind of out of the scope of this particular video. Now that we talked about the two ways that the system can provide power to the 120 volt outlets and the 12 volt devices and stuff like that, we need to talk about how this system can charge. So we're going to talk about shore power, we're going to talk about solar. And so let's talk about shore power first. So we touched on it just a minute ago, but recharging from shore power is simply the shore power cord that is connected to the outside of the camper. It comes in. All that'll get cleaned up later. Andy has more work to do back there. That white cable is coming into the inverter charger, and then power is flowing in from that white cord through the inverter charger using the charger function of this, and power is flowing back out through the red and black, through the Lynx distributor, through the red and black wires, back to the battery bank to charge the batteries. Now, if you're charging your batteries and using the batteries at the same time, it's just going to take the net of the power loss or gain. So for example, if you're able to charge at 70 amps, but you're using, let's say, 50 amps, you're only going to be charging the batteries at 20 amps. So power is going to basically flow in either direction depending on what is asking for power. We don't have to do anything to make that happen. That all happens automatically. And now we know how shore power powers the system, or is able to recharge and power the system. Now we're going to talk about the solar array up top and how the power flows into the battery bank, how that plays into the system now. We climbed up top, and on this array of solar panels, we have 8 100-watt monocrystalline solar panels from New Power. And they are wired in a series parallel configuration with these 4 panels wired in series and these 4 panels wired in series. And these 2 series strings are wired in parallel by using these MC4 connectors, and they go into the camper through this roof entry gland, and they go down to the dual pole disconnect before the charge controller. So the wires from the roof entry gland come in from the roof, and they come down over here to this dual pole disconnect. Got positive on one side, negative on the other, all the way through that disconnect there. And then it flows into the PV side of the solar charge controller. Since series wire solar panels get their voltages added together, we could see, 80 or so volts from our solar panel array. And the whole purpose of the charge controller is to regulate the 80 volts or so coming in from the solar panels down to a voltage that is more appropriate to charge the batteries at. So that is the primary function of what that does. So once that happens, power has flown in and it is going out of the positive and negative wires on the battery side of that down this way and into this terminal here through the positive and negative wires. Now, this is flowing this direction. Power will really never flow this direction unless there is a short downstream, which is why the fuse has to be here as opposed to the opposite end. Since the charge controller is a current limited device, this is the appropriate place for the overcurrent protection in this particular side of the system, and overcurrent protection over there would be inappropriate. So coming back over here, following the flow of power, positive and negative, through the positive and negative bus bars within the Lynx distributor, back through the switch, back through the shunt, back through the fuse, and then it would go into the batteries to charge the batteries. Now if we're using 12 volt power out of our 12 volt fuse block and bringing in power from the solar panels at the same time, we could actually be using 12 volt power directly from the solar panels to power our 12 volt devices out of the 12 volt fuse block. And that happens automatically. That's not something we have to deal with, nor is it something that we have to worry about. That just happens within the system automatically, no programming or anything like that required. And lastly, I wanted to talk about some of the communications cables and monitoring system wires that we had to install in the system. These are pretty quick. So since there is a little computer chipboard that you can't really see on the side of the BMV712 shunt that's behind this black wire, we had to run power to it. So there's this little tiny wire that's included in with the BMV712 kit from Victron that is attached over here. This is where I like to attach this. If you decide to attach this elsewhere, similar to this one, be sure to never put this ring terminal between the fuse and the bus bar itself. Over here on the Victron Multiplus, we have the VE Bus Smart Dongle over here on this side, which allows us to communicate via Bluetooth with this device. We have on that side a positive and negative power wire, as well as a communication cable, which is simply a Ethernet cable or RJ, I think 45, and that flows up into here and feeds and pulls information from the Multiplus. And we're getting power out of the Multiplus from this negative and this positive wire that are feeding into that module over there. And one more thing on the BMV712, there is an RJ11 cable, which is a standard like telephone cable that comes out of there, and that goes up to the front of the camper where we're going to mount the little actual gauge, so we can see at a glance what kind of power is being used or generated or anything like that in the system. And that particular wire is included in with the BMV712 Smart kit from Victron. So even though we have two different brands of components in here, you know, we have Battleborn batteries and we have Victron components. Battleborn batteries is a distributor of Victron components. Battleborn batteries, they just make batteries and they sell Victron components. Now why this is important is since they sell both of them, they have all the stats and figures and all the programming details and stuff like that on how to program each of these components in the BMV712. They have that available on their website so we can get that stuff right from the manufacturer. Programming this stuff is out of the scope of this video, and so I will put links to the appropriate information in the description, in the blog post, and in the pinned comment. And if you can't find any of that stuff, just leave a comment in the questions box. Leave a question in the comments box below, and I will try to point you in the right direction. So we drained the batteries a little bit just for testing purposes, and we can see now that we're getting about 424 watts of solar coming into the batteries. And that's great. That's a reasonable number. It's really hot out today. I'm not sure what the temperature is, but the panels are going to be well over 100 degrees at this point. And as panels get hotter, they get less efficient and they'll put out less power. So we can expect to see more power coming out of those as temperatures get cooler, as well as when we have direct sunlight. It's pretty early in the early morning-ish, but the sun is out, obviously. So we're not getting direct sunlight either, but that's a very, very good number, so we can see that. We can also check over here on the history tab, and we can see that today the highest wattage that we've ever seen at one point is 424 watts, and we have already made 420 watt hours. And to find watt hours, or to convert watt hours to amp hours, you can just take the watt hours divided by 12, and that will give you the amp hours into a 12-volt battery bank, which that's convenient because that's kind of quick math. I guess we made about 200 amp hours, so that's pretty nice. That's not correct. 12 times 10, carry the 1, times 2, plus... That would be about 20 amp hours. That's a little bit more reasonable. I thought 200 was a little high. So that's how much we've made just this morning. So that's great. We can also check out our BMV712 Smart monitor on the VictronConnect app, and we can see that we're actually pretty much 100% charged. And we can see that we are currently bringing in nearly 30 amps of power on that second figure down. Battery voltage is hanging out around 13.5, and we're bringing in 380 watts, and we're using a little bit of power. The inverter's on, Andy's running some stuff up front, and so that is showing all that information. We can also check through on our history tab, and we can see our deepest decharge. We drained 17 amp hours out of our battery bank earlier whenever I was running a heat gun, and that has all kinds of other figures on that. Lastly, we can check into the VE Bus Smart Dongle information, and that's just going to show that we are inverting power. We don't have anything on at this point, so it's only using like idle, which is 2 watts, which is really, really good. And it also shows that we are not pulling anything from shore because we are not plugged into shore power. And that wraps up this video. Thanks again to Andy for looping me in on this project. It was really fun to work with him on this long overdue project and bring you this tutorial. Also, special thanks to Battleborn Batteries and Victron Energy for sponsoring this video and continually providing the support that I need to make these videos and blog posts for you here on Explorers Life. And that's all for this video. If you enjoyed it or learned something new, it would be awesome if you would share it with somebody or a group who you think could use it. Hit the like button and leave any questions you've got in the comment section below. Go subscribe to Andy's channel, and I will see you in the next video.